Hi guys, today we're going to learn about power series and the interval of convergence and the radius of convergence. So, in the past we have studied a lot about infinite series such as the following. We have that when n is equal to 1 to infinity, the summation of 5 power n divided by n factorial. If you expand this, it's going to be 5. The first term is going to be 5 divided by 1 factorial. Then when you plug the 2, you have that plus 5 to the power of 2 divided by 2 factorial plus 5 power 3 divided by 3 factorial plus dot 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 dot. When you replace the value of the n for the n, you are going to have 5n to the power of 5 factorial plus dot 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 dot. So this is called a series of constants. As you can see, the dot 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 dot, it means that you have a series, okay? So this is a series of constants because if you analyze each of the terms, this is in number, this is a constant, this is another constant, this is another constant, this is going to be a constant, very big or very small, but it's going to be a constant. Each term of the series is a constant. Now, today what we're going to do is we're going to study infinite series that look like this. N equals 1 to infinity, the summation of x minus 5 power n divided by n factorial. What you have when you replace the n for the 1, here you have x minus 5 divided by 1 factorial. The second term is going to be when you plug the 2, so you have x minus 5 power 2 divided by 2 factorial, and then 3 power and then divided by 3 factorial plus dot dot dot, and you have the n term is going to be x minus 5 to the power of n divided by n factorial plus dot 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 dot, telling that it's a series. This is called a power series centered at 5. Why at 5? Because you have that x minus 5, you have that it's going to be x minus c, the center. So each term of the series contains the power of x minus 5, and you know that the center is going to be equal to 5. Now, let's move on to the definition. So, as you can see, if you compare the two before I go for the definition, you recognize that this is an algebraic expression instead of a constant. This is another algebraic expression, this is another algebraic expression, and so forth. So, each one of the terms is an algebraic expression. Okay, so that's why we call them power series. Okay, because you know they have powers and the powers change depending on the term that you are analyzing. Okay, so here's a definition. If x is a variable, then an infinite series of the form the summation from n equals 0 to infinity of a sub n x minus c to the power of n, it's going to be equal when you expand it to a sub 0 plus a sub 1 times x minus c plus a sub 2 x minus c squared plus dot 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 a sub n x minus c power n plus dot dot dot. This is what we call a power series centered at c. Now you can see why I put c equals 5 here, okay, because this is going to be your center, where c is going to be a constant like the 5 here, okay? So a power series in x can be viewed as a function of f of x, because we can name it, so it's easier for us to rewrite and to re-express the situation, as f of x equals the summation from n equals 1 to infinity of a sub n x minus c power n, where the domain of f is the set of all the x's for which the power series, please note this, converges. In today's lesson, what we're going to do is we're going to find this domain of the power series, okay? So please note something super important is that every power series is going to converge at its center. So at least worst case scenario, what you have is that your power series will converge at the center, okay? So I like the power series because they are pretty straightforward, okay? You have 3 possibilities, okay? For a power series centered at C, the first possibility is going to be that the series converges only at C. Imagine that you have a number line, okay? Always go back to your basics so you can use your imagination here. So let's say that C is here. So the only point where this beautiful thing is converging is here. That's it. Okay, so let's highlight that. The second possibility is when there's a real number r greater than 0 such that the series converges for x minus c less than r and diverges elsewhere. So what this is telling you, r is going to be what we call the radius of convergence. Okay. So what you have is you have your C here, okay, and you do know that that C, there's no question about it, it converges there, Okay, your power series converges there. Now what this is telling you is that there's a distance between C and another number here, that it's R, and then there's a distance, the same R, from here. So what this is telling you is that in between this, it's going to converge. Now, in this situation, there's going to be several possibilities that we're about to see in a second, okay? The third possibility is the series converges for all real numbers. So what you have here, your number line in this situation is you have your C, where we are always sure that my power series converges, but you also know that it converges everywhere else, okay? So the number R that we mentioned here for second option is the radius of convergence. If the series converges only at C, like here, the radius of convergence is going to be 0 because you only have a point in your domain. If the series, okay, you have that there's something, you are going to have an interval here. And your interval might be very exclusive, might be a little bit including one of the extremes or the other, or maybe you are including both extremes, okay? On the third possibility that you have, if the series converges for all real numbers, what you have is that your radius of convergence is going to be infinity. Therefore, okay, you are going to have that it's all the real numbers, your domain. This is the domain all real numbers, an interval, and then here is only at the center, okay? So the set of all the values for which the power series converges is what we call the interval of convergence of the power series, and that's what we are going to do in the following examples, okay? Please note that what we love about this type of test is that you're not going to be guessing which test to use. For the power series, immediately you are going to use the ratio test to find the radius and interval of convergence. Okay, so whenever you have a power series and they ask you to find the interval and radius of convergence, you are going to use your beloved ratio test. Okay, this test tells you that a series will converge if the limit when n approaches to infinity of the absolute value of a sub n plus 1 divided by a sub n is less than 1. So if you find that value, okay, and then determine the values of x for which the limit is less than 1. Why less than 1? Why we are using that magic less than 1? Because that is one of the conditions of the ratio test. Remember that the condition for converging of the ratio test is if you have that the limit of the ratio is less than 1, then the series converges. So that's what we are using here. Okay, so let's move on to some examples. The first example that we have here, they are asking you to find the radius of convergence and interval of convergence, and they want you to make sure to check the endpoints, okay? So what are you going to do here? Here you can recognize immediately that your center, by the way, your center is 5. Do you agree with that? Just by looking, you can see that the center is 5, okay? So that's the first thing that you recognize. You know that at 5, this power series will always converge. However, that's not what they are asking. They are asking what's the radius and interval of convergence. So what are you going to do? Well, you apply the ratio test to this beautiful power series, so you have the limit when n approaches to infinity of what? Here, remember that the alternating factor is not needed because the absolute value will take care of the negatives, okay? So I would put x minus 5 to the power of n plus 1 divided by n plus 1 times 2 to the power of n plus 1, okay? So let me get my ruler because otherwise my lines are horrendous, okay? So you have this. Then you divide, okay? By what? You divide by the nth term, so you have that it's going to be x minus 5 to the power of n divided by n times 2 to the power of n. So we have our absolute value, remember, because that's part of the ratio test. If you're wondering where is she getting this from, ratio test, okay? Now you're going to be like, oh my goodness, this is a monstrosity. Okay, remember, we're going to use what we call very user-friendly in Algebra 2, the sandwich rule. So you know that the numerator of the numerator goes together with the denominator of the denominator. Okay, so you have this, okay, this times this. Then in your denominator, we have this one, okay, the middles, okay, and the other middle that you have over here. Okay, so you have here your situation, and remember that this is with absolute value. So what I highly recommend you to do, and let me do my division here. Okay, what I recommend you to do is recognize here the patterns. I'm going to see what's the business with that, then what's the business with this part, and what's the business with the 2's. Okay, so you can see that the algebra is not that terrible. Okay, so what you see here is what can we eliminate from this situation? You can see that the limit when n approaches to infinity, you have that this exponent is greater, therefore you have an x minus 5. After that, you recognize that we cannot eliminate anything from this, from the orange portion of your highlighting, and then here you know that you have the 2. Okay, this one is greater, therefore you have a situation like this. Okay, so this one is less intense than the others. Now, note something. The x minus 5 is not affected by the n approaching to infinity because this is kind of like a constant for the situation that we have here. So let's put it here, x minus 5 here. In addition, the 2 is not going to change. So you know that a 2 with the absolute value, it's still a 2. So I put it outside the limit. Then you have the limit when n approaches to infinity, okay, of n divided by n plus 1. Okay, so what do you have that it's this? Okay, so you can see that this is going to be the limit. Just by looking at this part, you know that this limit is 1. Since this goes to 1, what do you have that it's 1 times this expression? It's going to be the expression. So you have this expression, but then you're like, now what should I do? Well, remember, what did we apply? The ratio test. The ratio test, we want to apply it because we want to know when this power series converges. So we know that the condition for the ratio test to converge is when it's less than 1. Therefore, that's why we put this less than 1. Now that we have this, focus only on this piece. This is pretty much an algebra 2 problem, as you can see. Okay, so we multiplied the 2 to the other side. So our problem now is solving this inequality. Do you agree with that? So let's solve that inequality so you can see that it's not that bad. To remove the absolute value, if you forgot from algebra 2, don't worry, I'll refresh your memory. You have a situation like this. Then you add the 5 to the 3 pieces, and then you have that here the x is in between 3 and 7. Now you might tell me, hey, is that my interval of convergence? Am I done? Well, not really. Why? Because, read the warning here, you must check to see if the endpoints are included in the interval or not. At least what we can find at this point is the radius of convergence. So, what is your radius of convergence? So, please note here that what we have, using the number line if you are more visual, okay? We have that C, the center, is 5, right? That's what we mentioned here. In addition, we found 7 and we found 3. So, what is the distance between 3 and 5, or 5 and 7? That's going to be your radius of convergence. So you know that that is 2. Are we okay with that? So you know that this is 2 and this is 2 as well. So your radius of convergence is 2. Now, we are going to attack the interval of convergence. We're done with this, and this is part of the answer, right? But we're not done with the full question. So you're going to see for x equals 3, you have another series. You need to plug the 3 here, okay? So what do you have here? You have the summation of n equals 0 to, not 0, excuse me. Let me erase it because that's not correct. Okay, it's 1, right? To infinity. And then you have the negative 1 to the power of n plus 1 times, and then you are going to put the 3 minus 5 power n and everything divided by n, okay, like this. Okay, so I plug the 3 instead. So what do you have here? Let's clean it up. You have this, okay, so you have negative 1 to the power of n plus 1 times negative 2 to the power of n divided by n times 2 to the power of n, okay? So now you might want to eliminate this, okay? You can, okay? Remember, from algebra 2 or 1, I don't even remember, you do know that negative 2 to the power of n is equal to negative 2 times 1, which is to the power of n, which is negative 1 times 2 to the power of n. Okay, that it's equal to what? Negative 1 to the power of n times 2 to the power of n. Do you agree with that? So let's replace the situation for what I just showed you. Okay, so you have the situation, negative 1 to the power of n times 2 to the power of n divided by 2 times n and the 2 to the power of n. Okay, so you have the situation. Now you're going to tell me what in the world I'm going to do, and I forgot to copy this, so what am I going to do with this? Okay, so let's go back to your algebra 2 info here. Do you agree that negative 1 to the power of n plus 1 times negative 1 times n is equal to negative 1 times negative 1 to the power of n times negative 1 times negative 1 to the power of n, which you do know that this is going to be negative 1 to the power of what? 2n times negative 1, which you know that this is going to be, since this is even, that's positive, so you have that this is just negative 1. Okay, so summarizing this beautiful series that it's presented here to you, it's going to be what? N equals 1 to infinity, and then you have that it's a harmonic series but with a negative sign. Therefore, what can you conclude? Thus, okay, you know that the harmonic series, what's the business here? This one diverges by P series test, okay, because P is equal to 1, okay. So what can you conclude here? So here in your interval, you know that you are not going to include the 3. Why you are not going to include it? Because the series will diverge there, okay. Now what we're going to do here is we are going to replace the x for 7, right? Now we're going to analyze this extreme. So for 7, what you have the summation from n equals 1 to infinity, and then you have that it was negative 1 to the power of n plus 1, okay? And then you have 7 minus 5 to the power of n divided by n times 2 to the power of n. So what you have here is going to be the summation from n equals 1 to infinity, and then you have negative 1 to the power of n plus 1, 2 to the power of n, okay, divided by n times 2 to the power of n. So as you can see here, very user-friendly, you can eliminate that 2 to the power of n, having something very beautiful here. So what do you have here? Look at this. This one is a alternating series, right? So it's beautiful, okay? So let's do all our conditions. You know that the terms, what's the business here? Alternate in sign. Check. Second condition met is going to be terms decrease in magnitude. You can see that it's decreasing in magnitude beautifully. And your third condition, you can see that the limit when n approaches to infinity of 1 over n, that's absolutely at 0. Okay, therefore, what can we conclude here? Thus, my series from n equals 1 to infinity, being negative 1 to the power of n plus 1 divided by n, converges by alternating series test, right? So what you can conclude here, and what this is giving you, is that you go back to your interval and you are including the 7, okay? So therefore, let's conclude. Thus, my interval, okay, of convergence here is going to be from 3 not inclusive to 7 including the 7, and that's pretty much it for this problem. Wasn't that nice? So for this new problem, what we can see here, remember, what are we looking for? The interval of convergence and the radius of convergence. So what are we going to do for this problem? Well, we're going to apply the ratio test. It's very original, this situation, okay? So not really, okay? So the first thing that you recognize, the center, you can see that your center, oh no, it doesn't have a negative c there, so it's 0, okay? So don't panic, you know better, okay? So after that, you are going to apply your beloved ratio test. Okay, so remember, we're going to not pay attention to the alternating factor, because the absolute value will get rid of the alternating factor either way. Okay, so you are going to have x to the power of 2, and here be careful, use a parenthesis. N plus 1, close it, plus 1, divided by, and here use parenthesis again, n plus 1 factorial. Okay, so all of this is going to be divided by x to the power of 2n plus 1 divided by 2n plus 1 factorial. Okay, so remember that always looks a little bit funky, the ratio test, but you know that we can clean it up very nicely in a second. Okay, so you use our sandwich rule, okay, the insides together and the extremes together. So let's clean it up. So you have the limit when n approaches to infinity, and you have that it's going to be x to the power of, distribute this 2 here and here, so that one is going to be a 2n plus 2 plus 1, that's going to be 2n plus 3. Okay, so then you are going to divide this. Okay, so you are going to multiply this times this one, so you have that 2n plus 1 factorial and then you divide all of this by the insides. The insides go to this one, you have that it's x to the power of 2n plus 1, and this one over here you also distribute the 2 here and here, so you have that that's going to be 2n plus 3 factorial. Okay, please do not forget to put the parentheses next to the factorials, because then that's an issue. Put your absolute value because you're applying the ratio test. Now going back to highlighting and things like that, let's see if we can cancel out stuff here, and let's see if we can cancel out stuff here. So what happens here? Look at the x's. If you apply the exponent properties, what happens here? You know that this one is 2n plus 3 minus 2n minus 1. You have only x squared there. Okay, then over here what you recognize is that the factorial, the one in the denominator, is greater by 2 terms. Okay, obviously this term doesn't cancel, but you also have that this term does not cancel. Okay, after that they cancel because they are pretty much 2n plus 1 factorial and so forth. Okay, so you have left this. You are going to tell me, well, I want to clean it up better like this, and then you know that x squared is positive, so there's no need of the absolute value. You do know that that is going to be positive, and then you have the 2n plus 3 times 2n plus 2, and there's no need of expanding this, honestly. Why? You know that this is a 1 over infinity. That's what your brain tells you. What's that? That's going to be a 0 times x squared, so that's going to be a 0, which by ratio test you know that the 0 will always be less than 1. Therefore, this is very nice. Okay, so what do you know here? Your radius of convergence, of convergence, aka r. What's going to be r? R is going to be infinity, because this power series will converge everywhere. So we can also see the interval of convergence. What's going to be the interval of convergence here? Well, it's going to be very nice because it's going to be all real numbers from negative infinity to positive infinity. So really nice. Okay, and that's it for this example. Our last example of the day tells you again, remember, what are they asking? Interval of convergence, radius of convergence, 2 things. Okay, so you are going to apply the ratio test. Recognize what's the center here. Your center is what? Center C equals 3, so at least it's going to converge always at 3. Okay, so what do you have? We apply the ratio test. So what are we going to do here? You are going to have the nth plus 1 term, so you have n plus 1 factorial times x minus 3 to the power of n plus 1. This is going to be divided by n factorial times x minus 3 power n, and all of this with absolute value. As you can see, this example is simpler. We don't need to do more algebraic movement here. So you can cancel out and compare here your situation nicer. Okay, so you can see that the factorial here, what happens to the factorial? You can see that the numerator is greater, therefore all the denominator will cancel, having only the n plus 1 left. On this side, what you have is that only again the numerator will survive. So you would have that it's going to be x minus 3 using exponent properties. So you have this beautiful situation. Now what happens? You might tell me, okay, I want to take out the x minus 3 because that's what we usually do. And I would be like, yeah, that makes sense. So you need to find the limit when n plus 1 and approaches infinity. So what happens here? So you have that this is going to be x minus 3, but this is going to be infinity. So overall, this is infinity. What the ratio test tells you about the infinity? As far as I know, that's greater than 1. So it's going to diverge by the ratio test. So you are going to tell me, so the series diverges everywhere? There's no radius of convergence? No. Okay? So you know that it always converges at 3. So what is the radius of convergence? Radius of convergence is going to be r equals 0. Why? Remember, this is like we have a number line, so this is going to be your 3, so it's only converging there. So how much you can move from there? Nothing. You stay there, and that's where your power series converges. That's it. Now, what is the interval of convergence? So what you know is that the interval, I cannot move anywhere. So it's only going to be at x equals 3, right? Because that's the value where your power series will converge. Okay? So I hope that you find this video helpful. Bye!